Okay, so hello everybody and welcome to our second webinar series within the wireless team at Rutronik about cellular and GNSS technologies. Today you have the unique opportunity to gain insights into the world of 5G and 5G RedCap, revolutionizing connectivity from high performance to IoT optimized solutions, which we are hosting together with Telematics. And yeah, I'm happy to introduce here Florian Densen, Director Product Strategy at Telematics, who will talk about the key use cases and applications for 5G RedCap technology, shows us the differences between 5G RedCap and existing cellular technologies, including the stages of 5G standalone networks and 5G RedCap adaptation, and dives into the evolving 5G RedCap device ecosystem and its huge market potentials. So before handing over to Florian, I'd like to briefly explain the schedule. First of all, we will record the whole webinar, and you will receive an email with within the next week with presentation slides and an on-demand live video. Which will also be available at YouTube later on and on the landing page at Rutronik. The whole presentation will be 45 minutes. And 1 hour, sorry, but Florian's presentation will be 45 minutes. And then we will start the Q&A session. However, feel free to directly type in your questions on the right sidebar. And afterwards, we will go through them. So, yeah, then it's the stage is yours, Florian. Feel free to join your presentation, and wish everybody a good time and good insights. Thank you.
Thank you. Okay, then let me share my slides. So, yeah, as introduced, I would like to outline a little bit NR RedCap and 5G, and also the positioning of NR RedCap within the 5G technology space. So starting off, maybe one of the first questions, what is NR RedCap? Why is it called NR RedCap? So NR RedCap is a 5G technology. It's positioned kind of for mid-speed IoT use cases, but also consumer use cases, for example, like wearables. There's a good fit. And RedCap translated means NR RedCap. NR is new radio, while RedCap is reduced capabilities. Initially, there were also discussions calling it NR Lite, written like NR Lite here, or just with the T. So you might run into also these kind of names for it, but officially it's NR RedCap. The presentation, what I'm trying to do is outline a little bit the standardization as a starting point, then the 5G system, quick overview, characteristics, because that's the foundation for NR RedCap, and then how NR RedCap actually came into place, also in relation, let's say, to existing technologies, and also how it somehow serves maybe different segments where there are overlays, or maybe some where it complements other applications. And then a little bit, not a very technical deep dive, but a little deep dive into the NR RedCap itself, the characteristics, and then networks are the foundation for NR RedCap. So there are some interesting specifics there. And in the end, a teaser on the RedCap products by Telematics. So the starting point, the standardization. So 5G was actually kicked off already in 2012 by the ITU. So the ITU assigned the 3GPP to carry through the standardization, to collect the requirements and have the standardization process going. And then in 2018, there was an initial release which was very much focused on consumer devices, on mobile phones. Already frequency bands had been auctioned. So the idea was to use these resources as fast as possible, and of course to launch the new technology everyone was waiting for. So that was actually the initial release, but not the official 5G, which was accepted by the ITU in 2020 and really had everything which was in the initial requirements inside. And then the question is, okay, how did it get to NR-RedCap? So from there on, that's quite some time until NR-RedCap showed up. So I'm trying to outline this a little bit. So, but first looking back maybe at the initial 5G. So the initial scope had three main aspects. There were some services defined initially. There were some performance characteristic also defined. And then as also a very important part of this spectrum. So there's new spectrum, a new frequency range, for example, with the so-called millimeter wave, which represents quite a big addition of spectrum. Yeah, like the extension is quite big, but of course it comes with special characteristics since it's so far high up in the frequency band. There's a lot of measures are needed to support this. And also in FR1, there has been a little extension. It was used to be called sub-6, and by definition now it goes up to 7 gigahertz. So these are the three main aspects. And if we now have a look at the 5G system, and let's say not all building blocks, but some selected main building blocks, we have services as they were defined, as we saw on the slide before. So the main services defined is EMBB, which is kind of the next step for the mobile broadband, which already existed within LTE. So it's enhanced mobile broadband. This is for high-speed applications, so phones, but also for IoT, industrial gateways and routers. Then MMTC, which is basically taking over the definition which already existed with LTE M and narrowband IoT and LTE. So that was a lift to 5G. What happened here? There were not a lot of new things or revolutionary things invented. Of course, the standardization is ongoing and features are added during standardization, but it doesn't mean a big, let's say, disruption or totally new ideas. So since in LTE, LTE-M and narrowband IoT have been working and served the use cases, there was no need to really change a lot. And then as a new segment, there is ultra reliable low latency communication, which is represented something new and is designed to really have applications which need very low latency, high reliability. So going into the more industrial space, manufacturing, direct control, can also be some medical devices in the future or other things where it's very important to have low latency and a high reliability. So that was actually something new. The other two services are an evolution from the existing ones. Looking at the performance requirements, in the middle, we see the LTE IMT Advanced and the 5Gs, the darker green. So we can see that there are some definitions which have been done related to the data rate, also user experience data rate, of course, spectrum efficiency, latency, mobility. So there was a set of performance requirements also introduced to be fulfilled. And as outlined, the spectrum edition. The GSA stated it's like more than 11 gigahertz of new spectrum is now available, which is quite a lot, but as outlined, comes with special characteristics, needs special antenna systems, and so on. Going further down to the more implementation part of 5G and how the system is realized. So one new aspect is, and that's also in something which didn't exist before, is virtualization, meaning being capable to have resources within a network virtually assigned to specific, it's called network slices for defined use cases. There were some initial defined use case, but it's also possible to have custom use cases defined. And the idea is to leverage a public network and being able to have resources for critical or special use cases assigned, so these applications can perform best with their characteristics they need. Another important point in 5G which was introduced, and that's also a step away from LTE, is having a new service-based architecture, SBA, which is much more scalable, much more flexible, and is representing basically elements which are connected via defined APIs, and therefore a more modular architecture is created. And also there is a separation between the user and the control plane, which allows, for example, to bring certain functions closer to the application in order to better serve it, or also in terms of availability, latency, to have some improvements. So the network itself became much more flexible and can be then, in a way, scaled to different use cases and requirements. So this represents really a new thinking about how to create network architectures. And then we saw there's a lot of spectrum to be addressed and to be used. So the flexibility in addressing this spectrum also has been enhanced. And this means that depending on the different frequency bands, but also in terms of requirements of the different communication services, for example, like ultra reliable, low latency communication, there's a great scalability, which means, for example, very short latency can be achieved by having specific sub-carrier spacing, which is then corresponding to this need. So there's a much more flexible way, basically using these spectrum resources and mapping them to specific performance requirements. And then, last but not least, there was also the idea, the learning from having basically a transition, which always happens if a new mobile network generation is being introduced, having this transition in a way made smart, that the existing resources can be leveraged and that there's actually an interworking between the previous generation and the new generation of mobile technology. And that was an important step also to enable this early launch in release 15 to be able to leverage actually LTE core network technology, for example, with some 5G radio spectrum and the 5G radio part. So it's within 5G basically an interworking defined to reach out to LTE to make the transition as easy as possible and leverage every existing resources. So summarizing the 5G standard, and the key concept is that there is a revolution within this new network virtualization, for example, the slicing, the architecture is also really a new step forward, and also there are new services which have been defined. While on the radio side, it's actually more an evolution. So the spectrum is added, the RF systems are extended, but not, let's say, completely new. I mean, for millimeter wave, of course, there's maybe a little bigger step, and the resource usage is optimized and enhanced. Yeah, so it's kind of a combination, and the logic of the 5G networks, the functionalities, they reside in this more revolutionary part, and that later, of course, is then also helping any 5G applications to have maybe better performance or new services like slicing, and that's then, of course, true also for RedCap. So coming back to the standardization now, looking at what happened after the initial 5G was accepted by the ITU, then actually we are approaching finally RedCap, and in the market-driven phase from release 17 on, there was another service added, RedCap, yeah? And this happened within the market-driven phase. And if we look at how the use cases were being served or have been served in LTE, then I think it becomes also very obvious why this was, let's say, an early need in the market-driven phase. So it happened right away after everything for the, let's say, core 5G toolbox has been brought up, that this was a very urgent topic to address. So to summarize, maybe there was this release 15 focused on eMBB, and they're mainly on consumer devices to have a fast time to market. This was supported by the capabilities of 5G to interwork with LTE. So frequency bands which had been auctioned could be reused or could be used for the right away, and it was basically a seamless experience for users for mobile phones. And then with release 16, we got all the initial services which had been defined way back, defined, and the fulfillment was there. ITU accepted the standardization done by 3GPP, and then the market-driven phase introduced the RedCap, also other technologies like non-terrestrial networks, so 5G over satellite, for example. And of course, some refinements were also done, as with mobile communication standards, continuously being done, like adding some smaller functionalities. But the main toolbox is really defined here, what can be done, and for example, also NTN benefits from this flexible architecture which has been defined here for 5G and is actually realized through that. So looking from a standardization timeline perspective, what we see is that in mid-2020, the standard was frozen and submitted. IMT 2020 5G has been launched, and then the market-driven phase started, and RedCap was defined also around mid-2022. And the story didn't end there. So there is another RedCap technology, which I will also outline a little bit later, which is the eRedCap in release 18, which is pretty new. So in 2024, the standardization has been done. So in the end, we can see we have suddenly 2 new services. And if we start maybe looking at the use cases and see how we got there, it's pretty obvious, because we had high-speed LTE, which transitioned into 5G. We had NB-IoT and LTE-M. For that, a 5G definition was done. Interestingly, not in the market today, since these technologies are quite working well, and even new products are released. So the definition that it plays with a 5G core is available, but the market is not picking up on it. Having the market actually well served already with LTE-M, and looking at RedCap later, we will also see maybe that there will be some transitions between this LTE-M, for example, and eRedCap. But in the middle, what we have, which we call mid-speed, is actually the initial LTE release 8, which at that time was high speed. From today's perspective is rather mid-speed, but this has been, as the first LTE, very long in the market and accumulated a lot of different applications and use cases. All the use cases which don't need ultra high speed, and therefore it's a huge segment which formed in IoT. And if we now look at 5G and what 5G brought, it's obvious that yes, we have an option for machine type communication, for efficient communication, for high speed. We also have an option, and we have even something new for this ultra reliable communication. But in the middle, there is no standard in the initial definition, and that's why RedCap had been brought in. And if we look at the initial release, it's basically some sort of let's say upper mid-speed, and then in release 18 there was suddenly the eRedCap introduced, and that serves more lower speed application, let's say in the mid-range spectrum. So it means there could be an overlap with, for example, LTE-M, and I will have some figures on performance, and then it's clear that there is a slight overlap here, while with the release 17 RedCap, the speed is even a little bit higher than with LTE Cat 4, and there might be some applications, maybe some use cases which are high speed eMBB before will maybe go to RedCap release 17. And then there's also an interesting relationship to this more industrial space, not in terms of low latency or the ultra reliability part, but these applications are often happening in dedicated private networks, for example. And RedCap is, in comparison to LTE, mid-speed capable of addressing these spectrum range. So before it was eMBB, which could address private network spectrum. Now with RedCap, it's also possible, and therefore there might be some not so critical application out of this space being served then with RedCap, which represents an interesting mid-speed option for these use cases. So performance figure wise, and that outlines maybe a little bit better the overlap. Release 17, the initial release, is a little bit faster, is similar to LTE Cat 4, but we can see it's a notch up in performance. It can serve FR1, the FR1 spectrum, and also in theory millimeter wave. It's not restricted. It's, of course, what will be available in the market is a different story, but it's not in a way reduced that it can't serve a certain spectrum or is maybe only constrained to FR1. This is only then a product decision, but the standard would allow also FR2. And in FR1, the bandwidth is 20 megahertz, so that's less than the 100 megahertz for eMBB in 5G. And in FR2, it's 100 versus 400 in eMBB. So it's the bandwidth is a little bit reduced, but not the frequency spectrum. Then single antenna operation is considered, which of course for many IoT application is very interesting from a design and cost perspective. It can only have single band operations, so no carrier aggregation, not like in 5G eMBB, where many carriers can be addressed in parallel. And then a very important point, it's standalone, 5G standalone. So it means it relies on a 5G standalone network. So this transition from LTE to 5G, where LTE resources are used, like an LTE core, for example, this will not work with RedCap. This was a decision to simplify it, so not only to reduce the bandwidth, but also to simplify a little bit this interworking. So that's an important point, because that means the network has to be, it has to be a 5G standalone network available to serve RedCap, or Fallback has to be integrated. And then there are some power saving options also integrated, which is of course interesting for a lot of application. If we then look to the release 18, it's comparable to LTE Cat 1. So it's a 10 megabit per second downlink and 5 megabit per second uplink. About, I mean, the exact numbers that might vary a little bit, but in this range. And interestingly, from the functionalities, it's quite similar, yeah. So there's not really a lot done. It's mainly really reducing the throughput, and of course there will be some additional power saving options in order to serve more efficient use cases, and that outlines a little bit why we're here, maybe at the border between the energy efficient use cases and the lower mid-speed served by RedCap have maybe a little bit of transition here and an overlap. Looking from, let's say, the timeline perspective and the evolution of the 3GPP technologies, I think it becomes pretty obvious that there is a long distance until there is 5G mid-speed technology, and a lot of applications are today in IoT centered around LTE Cat 4, LTE Cat 1, or Cat 1 bis, which also falls in this. And this all comes as outlined from the initial release 8 in 2008. And RedCap will try to absorb these applications and guide them into 5G, enable new functionalities, help to leverage basically the whole 5G feature set. And from a positioning, like the RedCap will be below and as outlined, overlap a little bit with the MTC use cases probably. And for the 5G, I think the evolution will go on in terms of performance, while RedCap is pretty much defined, and RedCap is even defined from a throughput perspective. Market availability, RedCap is being launched currently. RedCap, I try to outline here a little bit. I would see 2026, maybe late 2026. There's currently the standard is available, but now the chipsets have to be defined, and so that will take some time until then we have actually devices or modules in the market. To look at the use cases in comparison to the different, let's say, technologies, we can see that the mid-range, we have a broadband here from connected assets, classic remote monitoring and control, telematics is in their alarm system. So it's quite a range of applications, up to even video applications, which are perfectly fine with LTE Cat 4 if the resolution is not like super high. And this kind of mid-range gets a little bit extended, as we can see here, through the higher throughput of RedCap. And then in terms of, let's say, power efficient applications, RedCap can definitely, eRedCap, sorry, and this should be eRedCap here. eRedCap can do a little bit more. That's why it will extend into these lower segments, having maybe some advanced metering or everything like, which is having or relies on batteries and doesn't need the high performance, the high throughput. So here we will see a lot of designs served probably by eRedCap, especially also for future proving. This is very interesting. So looking now a little bit closer into the technology. So 5G was release 15, as it has been launched already, offered quite some throughput and quite some advanced mechanisms to leverage the spectrum. So and we have MIMO antenna systems. Then we have carrier aggregation, for example, being introduced, multi-carrier. So basically, the way how to address or how to gain throughput is to capture more spectrum, being able to address more spectrum. And what this means is higher throughput, but also the complexity and resource interdependencies are increasing. If I'm grabbing, for example, in parallel several carrier, then the characteristics of these carriers are different. They are maybe located somewhere different. So one breaks away in mobility and so on. So we get a lot of throughput, but we have a much more complex system we have to manage. And in NR-RedCap, the idea was to say, okay, we keep it very basic. This is the spectrum handling, how we address basically the resources. And therefore, we don't have the performance, but we also have a much lower complexity and can serve the mid-speed use cases and being in comparison to eMBB more price competitive, or having not also maybe such a complex antenna system, which in terms of implementation is also much more difficult. So the special things about NR-RedCap, it's a standalone technology as mentioned. So it needs 5G standalone networks. In the beginning, like of the introduction, that's why fallback is a must, because we don't have standalone networks coverage globally, not even in regions. It's difficult to have, let's say, everything with 5G standalone right away from the beginning. So the networks are built out, but it's still ongoing. That's why fallback is very important, very critical for the initial RedCap devices. And then power efficiency is basically introduced in 5G with NR-RedCap. So we have a power efficient technology now being in the 5G network, which before we had only with LTE-M and narrowband IoT and LTE. So that means more functionalities to use, but also in terms of device design, it has to be acknowledged that there are some configurations maybe to look at, and in the concept of the device, there are some things to pay attention to. And of course, this then is different when I'm in fallback, then I'm maybe having LTE, while if I'm in 5G, then I have 5G power saving options. So the device concept is very important, and also the understanding that the networks will transition to standalone, and then maybe the device in the future after it's deployed will have more options in terms of power saving. Then the market is very broad, as outlined. It's really, it's the center of the IoT applications, and there will be many use cases. And the decision making, starting with a RedCap release 17 with fallback, or maybe then adding RedCap for a different device category is I think important. So the use cases really need to be mapped well to these technologies, and also, as outlined, it's important to really leverage the 5G options overall, because this smart new 5G toolbox behind is really the revolution of the 5G standard. And so that on the application side, of course, is very interesting for some applications. So just looking at a table comparison between RedCap release 17 and release 18. So both need standalone. So that's why, release 17 will have fallback. Release 18, when it's being launched, might also have fallback, of course, not such a heavy fallback as here, where we need LTE Cat 4 to maintain the overall kind of performance picture. But release 18 RedCap will be in the sweet spot with, of course, standalone networks, because then the design can be really made very lean and very efficient, and it can really go lower and also be an alternative to some LTE M applications or modules. So the throughput, as outlined, we're looking here at LTE Cat 4 ranges, while we here have LTE Cat 1 about. The bandwidth is reduced for both, and interestingly here, the bandwidth wasn't further reduced. The idea was to maintain basically compatibility, to have not a different, again, a different device class with a different bandwidth to serve. Antennas, similar, half duplex could be an option for more efficient module design, for example. Modulation is, the high modulation is optional. So this is also a way to reduce complexity, have leaner chipsets and more cost-efficient devices. Power saving is available and will be enhanced with RedCap. So in general, in summary, RedCap release 17 has reduced hardware complexity if we compare to eMBB. There are efficiency options. There are many configurations options in the standard defined, which then will be leveraged by the chipset. And it leverages the full toolbox of 5G, which is very interesting, for example, private networks in the future, or network slicing and other functionalities. RedCap, RedCap is a new device type in comparison. So it's basically a throughput definition, and this is the starting point, and the sweet spot will definitely be NR only for very compact designs, and no fallback, of course, will make future modules much more leaner and much more cost efficient. So the decision making here with RedCap was, there is a need in cost optimization, but there should be a very, very little difference to the RedCap, to not have something completely different again, which the network needs to handle and manage. And so the focus is really find ways to reduce the UE hardware cost, to focus on the hardware rather than on the network and the definition of bandwidth and so on. So the bandwidth stays. There is a way that the bandwidth is reduced then in active mode later, but the device has to operate first in the whole 20 megahertz. And the feature set is similar to RedCap, so there will be some variations, but I think the main one for RedCap release 18 will be to have a cost-optimized hardware to bring everything down to achieve the 10 megabit throughput definition and yeah, be cost optimized in that way. So it's a device class. It reuses basically, yeah, most of the signaling with RedCap, so it's not something completely different. It can play as well with the 5G system, and probably the design or the challenges will be to optimize the RF, optimize the chips to reach into, yeah, kind of cut one and lower areas later. Fallback, as outlined, is a main factor with the initial RedCap devices, and later will probably, of course, then fade away. But for the first years, that's necessary, and depending on the regions, maybe longer. So we need fallback. We need also then an LTE category depending on the configuration. So for the initial NR RedCap devices, it will be LTE Cat 4 fallback. There's also in theory a way that it can work as an eMBB device in bands where the bandwidth is not beyond 20 megahertz, so it somehow can in theory serve these smaller bands. As outlined, the fallback is definitely part of the initial devices, and fallback mode, of course, has to be acknowledged in the application, and the application design has to be optimized to deal with that, and also later to have, let's say, the transition to SA somehow already designed in. And eRedCap has a clear standalone sweet spot without fallback, but initial devices might come also with fallback. And the regional rollouts basically determine when standalone is used broadly. So as outlined, it's important to understand when to launch and how to maybe reconfigure the devices along the life cycle. And for testing, fallback, of course, has to be part of the test scenario, and the power saving is of course something to keep in mind and to accordingly test. Maybe a quick one, and I know we're already late, so just outlining a little bit the transition between LTE and 5G and the different network options which have been defined. So launching 5G, it was possible to use a 5G radio part on the LTE core network in parallel, maybe to an LTE ENB, and therefore leverage the frequency. So this option here is for eMBB, still probably a main operational options. The target, of course, is always to have a full 5G system without any LTE elements. If we look for NR RedCap, in theory, what's possible then, all the other options mixing the equipment is of course not available. So NR RedCap needs this full 5G network, or in fallback just jumps into a clean LTE mode. This in-between part is not possible. So just to outline a little bit. So these network options definitely are reduced for NR RedCap due to the missing interworking support. So speaking about the network availability, this is a GSA map. So a lot of regions committed to standalone 5G in Europe also, and there are several MNOs, of course. It's not a single MNO here, but we can also see that there's still non-standalone 5G happening in many regions. So RedCap operation what kind of mode it is working. If it's working a lot in fallback, depends on the region, depends on the build out. And of course, in the future, we will have more and more standalone networks. Looking at the predictions of the number of connections in this case, there are some pretty high predictions from Omdia, for example, which are maybe a little bit too high, but they outline that RedCap really may play a vital role for IoT and be a, let's say, a good complement to eMBB for all the applications which don't need the throughput. So Omdia, in a very new study, says there will be by 2030, almost a billion connections of NR-RedCap. So that's quite some big numbers. We will see how that rolls out. So coming back now from the standard really to the application and device part. RedCap is available in release 17, and how these applications look like is outlined here a little bit. So there is fallback, of course, included in order to work across different regions. It's also possible really to have global variants, with a lot of bands supported, similar to eMBB. There's many bands supported. The spectrum range here excludes millimeter wave, so FR2 we will not see in initial RedCap devices. The question is when it will show up and how, maybe in some special use cases. But here it's the full FR1 spectrum, almost from 600 to 7 gigahertz, which is supported. Very interesting private network support, so new use cases which today rely on heavy, big eMBB technology can be served now with some leaner devices and connect maybe more machines or more things than was previously with eMBB. Power saving functionalities are available right away. Also, it's of course a very advanced hardware design in general with latest processing implementation and so on. So it has processing capabilities for embedded processing with app zone. GNSS is also included, and the footprint, we designed the footprint in a way that it's compatible with, for example, LTE Cat 4 devices. So the transition is easy. Products can have, let's say, dual SKUs. And an eSIM is also included, and connectivity, of course, also with Next. And since it's a very recent design, it has the state-of-the-art security functionalities also included. So that's how, let's say, a real product looks like today. And of course, it's a starting point, and we will see probably many more RedCap products and eRedCap products in the future. Looking then into the overall portfolio, it is a step within the portfolio towards from LTE to 5G. The footprints are compatible. There's also a data card option, which might help also for use cases which are maybe more like routers or gateways or so. So we have initially 2 products which we are now bringing to the market. So in summary, RedCap is here. It's out, and we are supporting customers now with the technology evaluation and designing IoT devices. In order to get the best performance, it's very important that the application and is aligned with NR-RedCap, leveraging all the new options, but also taking into account the fallback and other factors. So yeah, we are hoping to really support this in a way that applications can benefit best from this new technology, and yeah, trying to help to have everything outlined in a way that applications can power save, can handle the fallback in a smart way, and maybe later then have a smooth transition to standalone. And also in terms, of course, yeah, evaluating and testing the technology, I think is a very important step here, because it's not just another LTE, it's a whole different network behind it with many more options. And so private networks as outlined, I think could be very interesting, could be a very interesting field, not only for manufacturing, but also for smart buildings, building management, and maybe also some kind of yeah, networks which are maybe private by network slicing for some applications like medical, for example, that could also become very interesting. Yeah, so and RedCap then later, but we have to wait a little bit for that, will definitely be an interesting alternative for efficient machine type use cases. With that, yeah, I close my presentation, and yes, happy to answer questions around NR-RedCap.
Yeah, thank you, Florian, for your presentation. Very detailed and very interesting insights. So yeah, let's directly jump into the questions. We have quite a few. So the first one is, when can we expect 6G to be standardized?
So 6G standardization has been kicked off, is being, let's say, in the making. But as we know, with IMT 2020, 6G as IMT 2030 kind of outlines a little bit when really to expect something. So I think important is that 5G standardization is ongoing. As we see, we have a market-driven phase, so we can expect to see new functionalities as RedCap, as a new service comes. So 5G is not over. And what we saw with the transition between LTE and 5G to make both systems kind of like interwork, with 6G we can even expect further efforts to make it a very smooth and not this kind of jumping from generation to generation approach.
Thank you. So then the next one, will Telit design RedCap and eRedCap module in the tiny XE310 format?
That's a very good question. So it's a powerful platform we have out now with the initial NR-RedCap devices, which supports a lot of bands, which of course then contributes to size. So I would expect with eRedCap we have let's say a better chance to achieve this. With the initial technology footprint, that's yeah, quite challenging. It would mean to reduce so much that there wouldn't be maybe a product which makes sense being left. So I think eRedCap would be the target for such tiny optimized designs.
Mm-hmm. Then the next one is, how can we distinguish from LTE aided 5G and real 5G standalone when using a cellular network?
Yeah, so let's say the good thing is that it's a very smooth interworking going with eMBB, and it's a very good question, because for RedCap then it's important to have the connection management made in a way that this fallback is managed, because these networks don't know anything about each other when I do the fallback. So it's important to control the attach to LTE or 5G with a smart communication implementation, and we are working and helping to prepare something there and to support, yeah. And then the best performance is there. And later then, of course, with standalone, then this becomes less and less important. But in the beginning here, that's why it's a very good question. This is crucial to have a good implementation of the communication controller.
Thank you. Then next one, will RedCap support non-terrestrial networks?
That's a very good one too. So non-terrestrial networks is split into two camps. Yeah? It's NTN IoT, which is currently narrowband IoT. So it's MMTC, and then it's this other part where we currently have EMBB per definition, but EMBB, of course, and RedCap are very close. So currently, it's not, but it will eventually be part of this, let's say, mid to higher speed NTN. Yeah, but currently there is no support.
Mm-hmm. Then the next one, will RedCap replace LTM?
I think potentially in for some applications, but it depends on, let's say, also the type of application. If it's really a very focused application, then of course LTM or narrowband, or let's call it MMTC, is very suitable. But any application which wants to leverage the 5G core network functionalities more and is maybe a little bit more advanced, for sure will have maybe an improvement with RedCap.
Mm-hmm. Then another question, speaking global coverage and fallback, when do you think 2G will definitely be no more necessary? For example, a global container tracker in every parts of the world.
Yeah, that's also a good question. Yeah, so 2G and in many major markets it is already out, but for some regions it's still there. Yeah, so if there's something like global applications, maybe in the end NTN will help a little bit there. Yeah, before all the 2G networks are let's say switched off or replaced with LTE or 5G. So I think for this challenge of having global applications, maybe NTN might be the technology, because then it's a clean approach. It can use NTN while out of the network, maybe also in areas like if it's something with container tracking on a boat or something like that, then it suits actually very well the use case, and then maybe that could be much better. And then when it's back somewhere where it has terrestrial coverage, then it just goes to narrowband IoT, for example.
Mm-hmm. Then the other question is about the price ranges for RedCap and eRedCap. Can you give an range? Yeah.
So RedCap will be above LTE Cat 4. Cat 4, as we saw, introduced in 2008, has been really on a long cost down curve, while RedCap is being introduced now as a 5G technology, including fallback. So that positions it between EMBB, what we have today for 5G, and LTE Cat 4. For eRedCap, depending on the decisions of the device design. Yeah, we have a flexible definition, we have a toolbox, and within that, decisions can be made to have very cost optimized products. So if we take into account, let's say we have standalone networks and we operate half duplex and have a real reduced design, then we might, in some years when the technology also goes into volume, that we approach a little bit more the range of LTE-M. That is could happen, but then we are talking about yeah, if we say 2026 maybe as the launch, then we are more looking at, I don't know, 2028 maybe or something.
Mm-hmm. Then the last question is if RedCap is backward compatible with LTE.
Yeah, so as shown, it's only in the form of a fallback. So fallback has to be integrated, and then there is a compatibility. The part of interworking has been cut out of RedCap to achieve this reduced capability, to achieve a leaner design. So that's one of the things which has been taken out, and that's why the initial launch happens with fallback, as it was always like with 2G, 3G, for example. Yeah, this is the classic transition, actually, we already know. And then, yeah, later with standalone, then we don't need that fallback anymore.
Okay, thank you. So these have been all the questions. Now, just share my last slides to give you a short, like instruction or help. So if you want to get further information, you can get into direct contact with me as corporate product manager, or you are, of course, free to fill out the contact form from Rutronik and get into, of course, direct contact with your regional sales agent. Besides, of course, we are happy if you have a look at our different Rutronik web pages, the Rutronik 24 web shop, as well as our normal web page. And then we also have rutroniktech.com, where we always write articles about latest product news of our suppliers, and on social media, of course. And before finishing, we want to give you a short overview of our upcoming webinars. So the next one will be directly tomorrow with Telecentarian as well. It's about GNSS and RTK, so the real-time kinematics, precise position monitoring, and this will be also the content of Unicore on the same day in the afternoon. And then we have a Nordic Semiconductor Kyocera AVX talking about antennas, and here Nordic about the latest DECT NR+, the world's first non-cellular 5G standard. So feel free to register here via this QR code. And thanks, Florian, for the presentation. Thank you to all of you for listening, and wish you a good start into the new week. Thank you.
Thank you.